So first of all, I'd like to introduce my colleague Rana Klein. And together, we're going to talk about the questions your AI can't answer. The first question that occurs to me when I see that title is, okay, which questions can't an AI answer? And we thought, why not ask that question of an AI? So we put that question into the GPT-3 AI from OpenAI, and it came up with these answers. For example, can a machine experience consciousness? What's the best way to achieve world peace? Now, I'm pretty positive these are indeed questions that an AI cannot answer. The trouble is, I don't think there is anyone who can answer these questions. So as an answer to our question, it's not so useful because the AI doesn't understand the context of the question. We're talking about the sort of questions that we can answer using our archive metadata. Because that metadata is very valuable. Its most basic use is to be able to find material, but it also allows you to work on a far larger scale. It's impossible to go to a reading room for an archive and to view every item to find out about the archive. But with data, you can work on a very large scale. And it even becomes possible to identify underlying patterns and trends in the archive that tell you more about not just individual items, but about what's going on with media, with history, with society. It gives a different perspective. It can help you to check the received wisdom. This is what everyone always says. Can we confirm it from the data? Or are we perhaps going to challenge it instead? And it allows you to discover new knowledge, to find those pearls of the archive that have been languishing in some dusty corner somewhere. But people aren't so good at working with data, we don't understand it. We need tools to help us. The most basic sort of tool is the one that will be able to search through the data so we can find what we need. Tools can also create new data, for example, via speech recognition, that make it easier to find items, but also tell us much more about the content of those items and help us to understand them. It also opens the door then to being able to analyze data so that we not only can find relevant programs, but we can also say, perhaps we want to know how the use of a certain word has changed over time. And AI has really revolutionized tools. There are lots of tasks that previously had to be performed by people that can now be performed automatically. We can even let data and AI tell stories together. If we type in the beginning of the sentence into GPT-3, it creates a story about this conference that we're all attending now. That the board of directors has appointed Mr. Ahmed M. El Sharif as the new chair of the board. So Brecht, I don't know if you knew about this, but apparently this has happened. So of course, this story is not true. The AI understands how a story should appear, and it's come up with something that seems quite plausible if you don't know anything about FIAT IFTA. But it is not a true story. To get truth, we need to add something else into the mix, not just data and AI, but we need humans as well, who can take the insights that AI gives us from data and weave those together into a coherent story that actually tells us something about the real world. Each of these elements, data, AI, or other tools, and humans have their limitations. And Rana is going to tell you more about those now.
Hello. The first kind of limitations that we're discussing today are limitations regarding the data. The data, we start asking GPT-3 what he was thinking, or she, I don't know. And it came up with that the data might be inaccurate, outdated, incomplete, disordered, and biased. And those are indeed shortcomings that reduce the quality and the results of your AI. Data also might be too heterogeneous, limited in scope, or just unavailable. We'll now dive in some examples and possible solutions for those limitations. Sometimes your data is just garbage. And of course, then an AI cannot turn it into gold. It cannot do anything with it. But a more suitable problem is when your data is imbalanced or biased or incomplete. We once received a question, which genres cover fake news most? At the first glance at the absolute values, it seemed clear to be the news genre. But then when we plotted the distribution of the data over the different genres, the news genre was overrepresented, and some other genres barely represented at all. So looking at the absolute figures here leads to wrong and unfounded conclusions. The solution here is to either work with the relative values or to search and find another data set. To always check your data for bias and completeness, but even if your data checks those boxes, it still can go wrong. If we want to answer the question, how often has robotics been discussed in TV programs over time? And the first half of your data was annotated manually by archivists, and the second half by an AI using topic modeling. It might be that those two are comparable, but it might also be the case that they are not. So this can lead to unfounded conclusions. You should always check whether the data sources in your data is comparable. It's important to check your data quality, but sometimes such a data set is just unavailable, just not there. And this also limits the questions an AI can answer. We were asked a question, was our current FIAT program at the forefront of discussing climate change? The one asking this question, of course, was hoping that they were, but we only had their data set at hand. It was really hard to find a data set for all the other programs that was comparable. And that was only for the Dutch programs, because we are the Dutch Institute. And finding a comparable data set for all the other programs in the world would be even harder, if possible at all. Apart from those data limitations, there are also AI and tool limitations that limit the questions an AI can answer. A tool might be, or an AI, might be unsuitable for the purpose. It might be based on different, insufficient, or biased data. And it might also be limited to specific culture or language. In UK, they tried to answer the question, who has tested positive for corona? And they used an old Excel format that could only deal with 65,000 rows of data. Data got lost, and hence the question could not be answered. Sometimes tools are not suited for the domain. Have people in the Netherlands become more negative about technology the last 20 years? This was a question that they asked us. And you might think, okay, let's try sentiment analysis. There are lots of open source tools, off-the-shelf commercial tools that can do this, right? But loads of them are trained on the English language. And of course you can fine tune, but then it's not out of the box. And the majority is trained on explicit opinions, such as restaurant reviews. And of course, in a documentary voiceover or in an interview, the tone is much more subtle. So the tools here don't match the question. Problems might also occur when the tool is not suited for the purpose. So speech-to-text tools were great if you want to search through your archives. I personally wouldn't use them to create subtitles and publish them without a human editor in between. And the current AIs are limited by their capability to interpret the data. They often lack domain knowledge and are not trained to interpret their own results. You can solve this by using another AI or human expertise. And that's what our last kind of limitations are about, human limitations, which Mary will tell you more about.
So humans play an essential role in the process of trying to answer a question or tell a story using data. They're needed for many tasks, including defining a research question. So what are we trying to find out in the data? Do we want to know how propaganda has changed over time? And translating the research question to a data question, something that we can actually measure. So defining some terms within propaganda and then seeing how those terms have been used over time. Humans need to use the tools or AI correctly, interpret the results to see what they mean, then carefully evaluate their conclusions. Can you really say this given the data analysis? And they need to communicate those results to other people in such a way that they are accurately understood without bias or distortion. And these are not easy tasks. But what is more, a lot of people who work with data are not even aware they need to be doing these tasks, and that can lead to problems. A classic case is if you have a wonderfully interesting data set and you have a new tool or AI, then it's nice to go data fishing. Just let it loose on the data and see which results come out. But the trouble is data is so vast that you can get all sorts of spurious relationships. And there's a great website that documents a lot of the absurdities that can occur from real data, such as this graph, in which you see that we should clearly reduce US spending on science now to save all these lives from suicide by hanging. That is clearly ridiculous. But if you're not familiar with a particular domain, then it can seem like a perfectly reasonable result. So the solution here is to work with a research question and a hypothesis that really anchors you, first of all, in the real world, in what you really want to answer, so that you can then compare the data to that question and see what is actually a reasonable effect. Humans also have the tendency to think that the computer is always right. Imagine if I do some research about the number of women in the workplace, and I say that 10 years ago it was 60% and now it's 90%. You say, well, that's a fantastic increase in the number of women in the workplace. What about if I'm talking about a workplace with 10 workers? Then this is not a significant effect. So here it's important to have statistical knowledge, either yourself or from an expert, to be able to see what the computer says. Is that really meaningful in the real world or not? As humans, we love to make up stories. Ever since we were cave dwellers sitting around a fire, it's the way we communicate. And the trouble is with data that we tend to make up our stories with the data, but we think it's actually the data telling the story. If we take this example that looks at the speaking time of politicians in the run-up to the elections from the government, the left-wing opposition and the right-wing opposition, and it's really tempting to say, look, the public service broadcasters are completely biased against the right-wing opposition. And what's important at this point is to go back to that research question again, think, okay, I'm clearly interested in bias in the public service broadcasters, and I have some data observations that say that the speaking time is less for right-wing opposition than for left-wing opposition. But then I need to apply some domain knowledge and say, can I make the jump from that measurement of the speaking time to say that is due to bias? And in this case, you cannot do that, because an important piece of domain knowledge is that a prominent far-right politician in the Netherlands routinely refuses invitations to appear on public service broadcasters. So this graph is far from being enough to be able to answer a question about bias. You always need a research question and domain knowledge to check what your data is saying. Is that really answering your research question, or is it some other sort of effect? As human beings, we also like simple answers. Yes, no, guilty, innocent, good or bad. We also want those answers to be 100% accurate. We feel very betrayed if we have heard that someone is good and then we hear of an example where they've perhaps been bad. The trouble is that it's not possible to have 100% accuracy and simple answers. You have to choose between the two. So, and then it's important to have expectation management to say, okay, we're either going to have a very simple answer, which will be broadly true, but won't cover every single case, or we're going to have an accurate answer, but then it's going to be complicated and nuanced and have lots of gray areas. These limitations can have a huge impact when you're working on answering questions with data and with AIs. At best, you can have perhaps some slightly misleading results, perhaps a bit of bias. At the very worst, you have completely incorrect conclusions. And there is a notorious case of an economic study. It was very well known, and a lot of governments based their economic policy decisions on this study. It was calculated using an Excel, and some person who was very alert spotted that there was an error in the formula in the Excel, so a lot of data had been excluded. When you corrected that formula, the results were completely different. So all those economic policies had been based on a mistake. And that is something that you do not want if you're going to try to get useful information and to answer questions from data, to have it all be turned upside down by a mistake. So Rana is now going to discuss with you how you can avoid these sort of limitations and compensate for them.
Yeah, what can we do? It all starts with a team. You need at least someone with data knowledge, tool knowledge, and domain knowledge. And statistics underpin all three of those. It also helps to think through the process. Start with a clear research question and a hypothesis, and then analyze the data and check against the question. Make use of reviewers, not only for maybe the paper you're going to publish in the end, but for every step of the process. Your analytics, the data, just everything. And collaborate in all the phases with people inside your team, outside your team. Work best. In order to do good data research, you need a critical mindset. You need data criticism, tool criticism, but also question criticism. Can I really answer this question with the data that I have access to? Conclusion criticism. Is my conclusion actually well-founded? And does it, or might there be another reason why this trend appears in the data? It helps to make your process as transparent and reproducible as possible. And if you cannot answer the question, just stop. Dare to pull the plug. It also helps to realize that machines and humans are not the same. Not the same yet, maybe. At this point, machines are good at data and analysis, and humans are good in domain knowledge and interpretation. So combine the two, and get the best out of both. And that brings us to our conclusion. We started with the question to GTP3, a question your AI cannot answer. And one of the questions was, is there a God? It's a hard question, a question an AI indeed cannot answer. But the art here is to formulate an interesting research question that we actually can answer. For instance, how did the opinions about the existence of God change over time? And that's a question that you can answer together with your AI. You can use tools and an AI to find the material, and then a human to interpret it and draw the conclusions. Hence, the art of answering questions with data is defining a question that you and your AI can answer together. Now, it's time for your questions.
Thank you very much for this brilliant presentation. Is there any question? Yes.
Thank you very much for that presentation, and sincere apologies for that phone call that disturbed, but this was really fantastic. My question is obviously the combinations that you present that are interrelated to find the best possible solution require time, they require resources. How do you balance? And you spoke about the simple answer versus a simple answer versus the accurate, more complex answer. So how do you balance the two in a fast changing environment, a work environment that is commercial, and trying to make sure that you're actually getting the best possible output without compromising time and resources?
That is exactly what we ran into when we first started working with these sort of data stories, because we thought this would be so nice if you can quickly, if someone makes a statement and then you can fact check it with the archive, the next day you can come up with an answer. And we really found out that if you're going to do it carefully, no, it takes time. So these sort of data research, it really is, it's a project. But at the same time, what we're working on is to try and produce some sort of blueprints, but this is a sort of research that is done often. so that we can create tools that optimize that. We can also create ways of checking the data, for example, to see if the data set is balanced, so that we can say to someone, okay, if you're trying to answer this sort of question, here are these materials, they'll help you along your way, and then you can hopefully do it faster than if you have to try and do everything from scratch yourself.
Thank you for once again an absolutely stunning presentation. I found it very enlightening. May I ask you to take this one step further and reflect for a second upon the consequences for the training of archivists, catalogers, or maybe archives researchers? Because I couldn't stop myself from checking your LinkedIn profile, Rana, and I saw that you actually have a quite strong background in philosophy. And that's also what I recognize from my own master's in history. There are a lot of source criticism questions in being asked here. So there is often a lot of talking about future archivists should be trained in technology, and then they should all know Python, and they should all blah, 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 blah. But is there a need, in your opinion, to also reinforce that philosophical background?
I think the philosophical background might be even more important. I don't think there's a need for every archivist to learn Python, learn how to code. I think the important thing is to be aware that there might be a bias, to have someone that you can ask questions to. Okay, what tool is used? What bias is there in the data? I think at this moment, and like the next maybe 10 years, it will be a collaboration between AIs, between technology and humans. And those need to communicate. They need to kind of be able to speak the same language. So it's not important for them to know Python, but they have to know that we're talking about a programming language and not a snake. In order to communicate and ask the right questions to each other, and yeah. Does that answer your question?
Thank you for a good presentation. My question is just a minor one. As you tell us to stay critical, and you talk about data criticism, tool criticism, question criticism, and so forth. In order for us to stay in partnership or have that interdependence, humans and AI, are you suggesting that when we go through these levels of criticism, we use AI tools or we do our own statistical calculations? What's the best way out to drive a balance?
It's important to use the tools where we can, right? That's where they are for. But it's also important to keep the criticism, like to be critical yourself and check the tools. And so, do you agree, or maybe?
Yes, and I think that also links back to Brecht's question about whether everyone needs to learn Python. It's not necessary to understand how a tool or an AI works, but you do need to know its limitations and then apply that to what you're trying to do yourself. What is your question? So that is where you really need to be critical, as you understand your own question, and then you see what is the AI doing, and can the two of them work properly together or not? So you don't necessarily need to recreate the same calculations as the AI, but you need to check these things. Is it appropriate for your sort of data? Is it the correct sort of domain that you're working in? Those are the general sort of checks that you need to be able to do. And if you are getting an AI in for the first time, you don't know what its capabilities are, then it can be useful to do some benchmarking between what humans do and what the AI does to see, is it doing the sort of thing that you need to do, and accurately.
I'm not trying to have a conversation, but let's put it back in a real world context. For example, we are conducting a survey. You have more than 1,000 questionnaires, and each questionnaire probably it's got more than 50 questions, for example. now that you have to work on your descriptive statistics and also do some inferential statistics, that's a lot of work. In a real setting where as a researcher you have limitations of time and the scope of work, then you just run through everything depending on the tool. Let's say you're using SPSS to do the data analysis for you. That's a real world. You just take the results as is. There's no time for critical double checking if everything was, as you're saying here. I'm just saying that in the real world, you just assume that whatever results that you get from your tool that you're using, it's what you're going to present as the analysis, and then you continue to present the report. That's the real world situation. But now, ethically, is it correct, or you have to go back and be critical and double check if, you know, other things, the tool that might have gone wrong or right? In the real world, we don't do that. We just assume that the results presented, let's say we're doing regression analysis or probably a structural equation modeling, whatever results that you received, you present them as is. You never go back to double check if the tool did anything right or wrong, was it programmed correctly or not.
Yeah, you definitely don't need to go through the code of SPSS and check whether the regression is implemented correctly, because it's a tool that it's used often, right? It's not the first tool you find on the internet. If it's the first tool you find on the internet, you just use it without looking into the documentation or anything. Maybe try to find some documentation or, and also I imagine that the analytics within SPSS that you run, whether you pick a regression or a correlation or whatever, that's a decision you're making, right? It's not a random, like, let's run all the SPSS analytics that are in there and randomly pick one and then present it. So the critical step is like, what program do I use? SPSS is great, it's commonly used, so that's fine. What analytics do I use? Okay, here I need a regression. It's fine. What result does it give me? Is it indeed something that we expected? If not, why not? Where was like the mistake? And then in the end, if you're presenting the conclusions from your tool, that's where you have to be critical. That's where you can, like, have to ask the question, can I really, like, the conclusion that I draw from this, the outcome of this tool, is that indeed a valid conclusion? I think there it's important, especially to be critical.
So just adding one thing to that, it's of course always good to check if you're getting unexpected results, but that can sometimes also be a bit of a pitfall. That if you get the results you expect and you say everything must be working fine, if you get results you're not expecting, you say there must be a problem. So one way to avoid that can be to have some made up data, some very simple data that you know what the result should be. And you put that through your tool, and then you see if it's not coming out with the result that you expect, then you know straight away there's a problem with the tool. It's not always possible with everything, but it can be a way of checking the process.
Thank you. We got an extra minute remaining. Any other question? I may have one question on my side. I think it's linked to your question, actually. I mean, it's very easy to find AI services, data model. I mean, there are plenty on the internet, right? You go to Hugging Face and it's very tempting to actually download a model about like sentimental analysis, right? I mean, it's hard to train and no one knows, I mean, unless you've already done it before, how does it work? Is there any tips to quickly check, see if you can rely on this kind of model that you can find in a while?
Well, checks, definitely always read the documentation, trying to find out what the tool is and what it does. Online user groups to see what other people have done with it, especially if they've published papers with it. There are benchmarking studies that my colleague Rana has been involved in for speech recognition tools that you can compare the results of different things. And then if it is something that you can download for free, at least initially, then it's there's nothing better than having a small sample of your own data and seeing what it does. Does it perform with that? Does it do what you want it to do? Have anything to add to that, Rana?
Thank you. Thank you very much for this brilliant presentation. Thank you for your question. It was the last presentation for this morning. So thank you again.